Let's look at the classic DielsAlder thing, all right? Got the Dyn, got the Dynafile. So we know that these two come together the way that Dr. Emma has taught, look just like this. Show those. What I like to do is draw. You can draw a dot there and then have it go into there. So every DielsAlder product will have this basic structure to it. So always draw that first. So let's look at number 5. So the first thing you're going to notice is that this is your Dyn and that's your Dynafile, all right? This looks a little bit different, right? What you have to notice is that there's 2 sigma bonds separating the double bonds. In the traditional DielsAlder, the way that it must go, there must be 1 sigma bond between the 2 double bonds. So in this case, this is not an appropriate case for DielsAlder, and it's no reaction. Simply because this Dyn is not appropriate for this reaction. The Dynafile is valid, but this Dyn, there's no way for it to react, so no reaction. Number 6. So you look at your Dyn, you look at your Dynafile, and you notice, all right, we know that the Dynafile, or the Dyn, needs to be in the cis position, like this. That's trans. This is cis. So it needs to be in this position. So we have to figure out how we can rotate it to get into the cis position. Turns out you can't, because it's locked in. No matter how you twist and turn, it'll still be trans. So we got another no reaction. If you can't move it into the cis position, then it's just going to be no reaction. So let's take a look at number 7 then. So these two are not touching. So once again, we have our Dyn, the one with 2 enes, 2 double bonds, di, 2 ene, double bonds mean ene. And then we have this Dynafile. So once again, we see that this is trans, and you think about how you can rotate it to get into cis, and you can't, so you have no reaction. All right, the whole point of this was just to kind of get you feeling out like the no reaction, the way that it can appear, because it can come up a lot. You got your Dyn, your Dynafile. We know we have to put this into cis in order for it to work. And we could do that because we have we've got a single bond here, we can rotate it, get into that position. In order to set it up for the MS rules, the Montag-Smith rules, in order to follow these rules, you must set it up in this position and then follow his rules. You always make the dots from here to there. All right. This is how every DielsAlder is, every single one. You first draw this structure, no matter what, basically. That's it. Then you figure out how this stuff is oriented. So this here represents this here. And this part, the way this connects, represents the way that this connects with that. So if you can see them, it's like there's a hexagon right there. That's this hexagon, the way I do it. This is kind of how it is. Now, we look at our Dynafile, and you put, in order to follow his rules, you put it in the dash. And you'll get the right answer every time. In this case, yes, you could wedge it. But honestly, you can do it, yeah, it still is the right product, but only because there's nothing on this Dyn, because we haven't got into that yet. So this is valid, but just trust me and just always put it in the dash. So in order to see how this makes sense, we got to do a couple more. Let's look at 9. So hopefully you have the worksheet with you, and you're doing it along. So, all right, got our Dynafile, we got a Dyn. This is definitely locked in the trans position, and you have to be able to recognize this. You have to be able to recognize when you can and cannot rotate it into the cis position. Up here we could. So let's do 10. 10's a good one. All right, this is our first one where it's getting like to like the real thing. So you have our diene, and we have bonds going in, methyl groups going in, and then we have our Dynafile. Now, the diene is a cis, so we're good there. So what the next step, what I would do is you have to set this up so that it's ready to come together with the diene. So the diene is actually good the way it is. Then you have to fix this Dynafile. All right, so then this is the key point here. This can come together with this in this fashion, or you could actually, this can be flipped around such that it can come together this way. So in this case, there's two ways for these products to come together. Yeah, I live right next to a fire station, if you could hear that. Anyway, so let's look at this one. You do your simple trick. You come together like that. Draw your basic structure. Now, this is where the MS rules come into play. Big time. Okay? The inner substituents, these are going in. All right? In, up, out, down. So what that means is these substituents are going in. So that means on this, they're going to be up, which is the wedge. There are hydrogens here. And those are going down, so you don't really need to show those. Now, what I do is, whenever this is pointing like, whenever this is like that, you always put it in the dash. And this one is opposite it, so in this case, you'd put it in the wedge. So in order to clarify this, let's do this second one. So you give this one a shot. All right, these are pointing in, so they go up on the adduct. That's a wedge. You got two wedges here. Now, what I do is this one's going out right there, and this is opposite it, so it must be in the wedge. Now, if you try to flip these two products around, you'll notice that they are not the same. So these are our two products. Now, let's do another one to kind of solidify this. Let's do number 14. All right, so we got two problems here already. What are they? First of all, they're not set up right. This is trans, and this isn't in our position to do the MS rules. So we have to, first of all, put this into the cis. So we already know it's going to be like this. So you can go ahead and just draw that. Then you have to notice, all right, let's see. Say we took that, and we went like that. So we took it and we flipped it. Then you can imagine that this would be what you get, right? So give that a try in your head. You have to think about it. Now let's see how these would come together. Do your little dashes. So here's our baseline structure. Now these methyl groups here, let's just go ahead and add those in, because remember the hexagon that we formed? These are just along for the ride. Now, how do we address this? Well, what I would tell you is, in order to get the right answer, you put them in dashes. You put them, you see how these are kind of going out, this Dynafile? As opposed to like this from the last example. Well, what you do is when they're going like this, you always put them in the dash. So this, for me, I would put that one in the dash. And then this one's just the opposite, so you'd put it in the wedge. But these are both going the same, and obviously you dash them in order to get the right answer. That's how you do it. So the thing is, it's just all about practicing, trying to feel it out and figure out your method, or basically figuring out how to adopt these rules so that you understand them. because if you follow these rules, you will get the right answer every time. So anyway, let's do 11 actually. I want to do that one. That one looks kind of cool. And then we'll do a bonus one at the end. The bonus. So I'm just gonna go ahead and flip this into the position that I like. Straight up, right away, from the start. All right. So what do you do here? First of all, you got your dots. Goes to here. This one looks a little scary, but I can promise you that it's not. You make your baseline structure. There it is. It shows up every time. Now, we notice that these are going in. But then there's a bridge that connects them. Well, that doesn't really matter because they're still going in. So in this case, you would actually wedge them like this. So this carbon is represented by this right here, and this carbon is represented right there. And this carbon is represented right there. And this carbon is represented there. So this is showing 1, 2, 3, 4 carbons right there. It's basically showing the way this would look from a top view. All right, and that's the way I like to represent it. There's some other crazy way to draw it, like I don't even know. Don't mess with that. Well, you can if you want to, but I don't think it's very fun. Anyway, so you've noticed how, let's just go up here for a second. We got 2 here. 1, 2, 1, 2. And when we make our DielsAlder adduct, we have 1 bond there. So we notice that, oh crap, we have 3 here. So here we lost 1 because that's how it goes. So in this case, we're going to lose 1 again. So actually you just have 2 instead of, because we had 3 to start with. I'm teaching you tricks here. This is not really chemistry. Yeah. So you have your cyanides, of course, coming off because that's where they are. Why are they not dashed? Well, that's sp2. And sp2 is trigonal planar, so there's no stereochemistry. That is chemistry right there, though. That is chemistry, that part. So yeah, that's the answer. I hope this is starting to make sense. Okay, so straight up, set it up the way we want it. Once again, this is how you get the right answer. We're all about getting the right answer. So first of all, I see this going here. This is in. That means it must be wedged. So what I also saw once was this. Let me just do a little sidetrack here. Whoops. So I saw a student once ask, okay, what do we do here? Your product. And then she was drawing them like this because, like, I guess they're going in, so she wanted to put them in. I wouldn't do this because that's not really what we're trying to do. These should actually just be out because they're not being connected. So don't put them in there like that, put them out. But in this case, because we have a bridge here, we've got this bridge, this nice, bridge. We have to just bridge it in the middle of the molecule like that. So that's how we address this part. Now, what about this? Well, just dash that. Simple as that. And that's the right answer, 100%. Now let's look at this fun one. It's really fun. This one's pretty sweet because it just is. Okay. So this is number 13. Getting kind of excited. But I don't know if you are, but just hang with me. 13. You're probably going to want to watch this at double speed. I don't know. Who knows? So we've got a diene here, but it's got other stuff on it. So it probably makes some people nervous, but don't let it make you nervous. Just set it up the way you normally would. So we can see that this structure, this baseline, or that little, the way the cis is already set up for us. So we might as well just leave it. Sorry, it's a little messy. So you notice this structure can be flipped around so that it can come together with like that, but at the same time. And both of these reactions happen because these molecules are just, apparently in a bottle and they're just running into each other. So some of the time they're going to come together like that. Some of the time they're going to come together like that. So we must obviously take both into consideration. So start here. Both of these reactions are part of this same original reaction. You just must think about it in these two different ways, because there's no way to think about all of these at once. Anyway, so let's show our hexagon. Here it is, basically. So let's, like I said, baseline structure. You can already go ahead and put this in the dash if you want, because it's going that way, so you dash it. Now, how do we address this whole thing? So what you do is you first think about your baseline, your diene. There it is. You think about, okay, this is actually going out. So that means in, up, out, down. Or you can think of it like this. One student from last year said dash out. So it's out, so it's going to go in the dash. However you want to think about it. So there it is. You show these two dashes are represented by that, and this dash is represented by that. So then you just draw the rest of it. Seems crazy. A lot of people were like, what the heck? How do you do that? Like, how can you just do that? It doesn't really make sense. How do you think about that, like, in your head? It's a great question. I don't know. Don't worry about it. Just do your dashes. And then draw the rest of it the way that you would. And that is one of our answers right there. It's a big molecule you'd have to draw on a test. Let's do this one. Baseline. Should be getting good at this now. This is going kind of out like that. Well, it is. So you dash it. Simple as that. These are going out, so we put them in dashes. And then we just draw to represent, this part is right there, this part is right there. So that might take a little bit of getting used to. It's our second product. But that's how that works. And if you're like, oh wait, maybe these are the same thing. No, they're not. As long as you consider both, these are not the same. You flip this over, it's like, this is all wedged. It's not the same. If you follow his rules, one other thing, if you follow his rules here, then you must put this part in the dash the way I did in order to get the right answer. That's the only way it works. So if you follow his rules for the diene, you must follow the rules for the Dynafile as well. It's not just simply just following his rules in order to get the right answer. I know I've said that kind of like 1,000 times, but that's it. So that's 13. All right. So that can be scary. I get it. Excuse me. That can be scary. Well, don't let it. First of all, you notice that because this is a single bond and there's not like rings and stuff like that locking it into trans, you notice that then we can just put it into cis. So what I recommend is just going ahead and if you know that you can put it into cis, go ahead and just put it in. Start with that basic thing. Now watch this. In order to figure out the way that this is going to be like situated, so you're probably wondering whether these bonds go like in or like up or whatever. The way to do it is cover up one of the doubles and then look at what you've got. Look across this double bond here and look at the way the sigma bonds are relative to that double bond. You can see they're trans. This is trans to that. This is like a trans relationship. Therefore, because this bond is represented right here, just make them trans. So that's trans, just like that is trans. And that's how it works. So if you want to figure out the other side, you cover up that double bond there, and then you look across to figure out, all right, what's the relationship across that double bond? It's a trans relationship. Therefore, this must be a trans relationship. Let's do another one, because that might not be clear. Okay, pretend we've got this. So how are we going to reorient this into the cis position? Well, you cover up one double bond, and then we look at the orientation. And that's a cis relationship. So what we do is we pick one and we're like, okay, we have to make it cis. Because now that's cis. Forgetting about this one. These are both cis. Right there, and then boom, right there. So in order to get the other relationship, we must cover up that double bond there, so that we're looking across this. And we notice, okay, what kind of relationship is that across that double bond there? Trans. So therefore, this, and that must be trans. See? Trans here. So then 1, 2, 3. 1, 2, 3. It's the same thing. Hopefully that makes some sense. So then let's run with this one, actually. Let's just run with it. What will we do? We see that this is our given, that's our given thing. So we have to go both ways. That's going in, up, wedge. That's going in the out, so it needs to be down, dash. And then, if we follow his rules here, we must put these down in the dashes. Just like that. Same thing for this one. We get our baseline. That's going out, so we dash. It's going in, so we just put it up. And wait, what about these? Sorry about that. What about these? Well, if you follow his rules, you follow the dash rules. Down. And those are your two answers. Straight up. For this problem. Alright, I hope that kind of makes sense. Wait, you know what? Let's go back to this one. So we figured out that this is the correct way to reorient this one. So now it's just a matter of having some fun and making the product. So you do your baseline. That's going out, so we must dash. It's going out, you must dash. That is going, I don't mean to say that's going out so it's dash, that's not what it is. It's just to always put them down. But if, for example, if, this is important, if, for example, let me show you another one. If, for example, it was this, then what? And then what I like to do is I see this one like the way it is. So you dash that one. And then this one is just opposite, so simply just do the opposite, which is a wedge. The opposite of a dash is a wedge. And then obviously we need to consider our other view. What's our other view? This is our other view. Right? Because they can come together either, like both ways. You must consider that. That's going out, we dash. Now, I see this one there, so I dash it. This one's just going, these two are trans. So then this is put that in a dash, this one must be in a wedge. And that is how that works. That'd be two products. All right, so hopefully that's making some sense. One last clarification. So I want you to compare this problem against number 12, right? Number 12, compare these two. The product of this one is what? These are going in, right? So they're going to be up, but there's only one carbon here. Therefore, these meet in the middle, and they represent that one carbon there is represented by that little dot there, as opposed to two here, two carbons here. So then we have two carbons in our product, and that's why we need that bridge, because the bridge is shown here. However, with this little point, there's only one carbon, so it's just simply this big mess. It's weird, but that's just how it is. And then simply, you know, do the dashes. That's the way it goes. And that's your answer. All right, I got a really cool one to show you. All right, bonus. This one's a lot of fun, all right? This is Allie's problem. I think Allie made this one up. She's really good at making up really tough DielsAlder problems. Anyway, this was a problem. I want you to try to figure it out. So there it is. Say that's given you on an exam. What do? Well, work it out and then come back. Excuse me. So first of all, you don't want to get scared by all these substituents. First of all, you just notice your DielsAlder is in, the diene is in the cis position. So we're straight, or we're good. So what you do is this. You need to consider, okay, this is very asymmetric. And this is symmetric. So you're like, okay, this can only come together one way, but this can actually come together with this two different ways. So let's look at the other way. If you were to take this and flip it, then you get some weird stuff. Just imagine this. So that part right there is represented by that. And then you flip this down. So that's like that. And then that is bingo. Okay? So you must consider both of these possibilities. It should never really be more than like, I guess the worst thing that could happen is if you get a asymmetric diene and an asymmetric Dynafile, but don't worry about that. Just worry about the stuff that's on the old exams. That's as difficult as it'll get. So now, do that. Do a little bit of that. Draw your DielsAlder, your baseline DielsAlder adduct. This thing is just coming along for the ride. They call it a methyl group. And then this thing is going in. So that means it must be in the wedge. This thing's going out, so you just dash it. This big old ethyl is going in. So you wedge it. In, up, out, down. Or dash out, and then you know the other one is just whatever it is. That's going that way. So we always, if you follow his rules here, with the in, out, up, down, you must put these in the, you must put them in the dashes in order to get the correct product. That's it. That's all there is to it. Same thing here. So you first just take a look at that. That's going along for the ride. There it is. That's going in. There it is. That's out. So go ahead and do that. That's going in. Well, the first part's going in. The rest, I mean, that's going out technically, but who cares? That's in. So there it is. And then, wait, what about this? What do we do here? Well, you should know by now that you just go ahead and wedge it, or you dash that. And just like that, you've got your two very complex looking products. But you would need to show both of these on the exam. What I showed you today was how to get what's considered the endo product. That's the only answer that's going to be accepted on the exam. And I showed you how to get those products. Every single product I drew was an endo product. And it was the major product, and that's the only product you need to draw. So let me know if you have any further questions on this. But other than that, let's just do a what do you call it, a review. So first of all, you want to make sure your diene is cis. And you always orient the diene like that. You always orient the Dynafile like in that position so that you can bring them together. This is the most basic diene and Dynafile there is. If you order them like this and you follow his rules, you really can't go wrong. So then for diene, you go in, up, out, down. You follow the rules on the with those substituents and all that business. And if you do that, then on the Dynafile, you put it in the dash. Unless, of course, you've got like unless, of course, you have like a thing like this, where these are going in opposite directions. You put one in the dash. I always like to do this one, and then you make sure that this was in the opposite direction. That's the only caveat, really, with this whole thing. And you got to check for both, all the ways that they can come together. Other than that, I think you're gonna be golden on the DielsAlder. And if you're not, let me know, and we'll try to work it out.